I'm going to present my report in data analytics and visualization. My name is Jeline Manipis, and I am a student in Leeds Beckett University. So allow me to share my PowerPoint presentation. So my topic will be all about power consumption analysis in Tetuan city in Morocco. So for the data set that I am using in this report is from the UCI machine learning repository, and it's called the power consumption, titled Power Consumption of Tetuan City Dataset. Convert it, and then so that it will be easier for us to visualize, to plot the data and create charts. The goal of time series forecasting is an approximation task to estimate future values of observation based on present and historical values of the sequence and the development of model describing the underlying relationship. Our data set that was collected from the UCI repository. So we have here our data set is related to the power consumption of 3 different Tetuan distribution networks. So there are 3, the zone 1, 2, and 3. The data set contains 52,416 energy consumption data points in a 10-minute interval. So there will be 10 minutes intervals from January 1, 2017 to December 30, 2017. So that is 1 year data. However, there are few other SQL-based and XML-based machine techniques to take into account in this area, because this report is an academic project that has no connection to business. So some knowledge discovery database procedures like selection, processing, transformation, and data mining are employed in customized manner. Additionally, there is no deployment of post-HDD step for this report. So we have here the dataset features that we can see also in our Jupyter, in our Jupyter notebook data. So we have here the date time, which is time window of 10 minutes. As you can see, we have here the data head of this data set. So this will show 5 columns. So we have date, time, temperature. It is weather temperature in degrees Celsius. The humidity, it's the weather humidity percentage. When wind speed is in kilometer per hour. In the general diffuse flows and the zone power consumption in zone 1 up to 3. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 what do you call this? Categories to our data set. You will also see this one in the methodology part of the report. So we have here the source. I have indicated the source of our data set. So it is essential to adhere the consistent process to guarantee accuracy of the data analytics and visualization report. So we have used KDD or the K knowledge discovery database, and also the artificial neural network. Or AN. Neural networks are data-driven machine learning algorithms that draw inspiration from how human brain function. So in data preparation, so we have here, and we have presented the features and the target variable. So we have already imported our CSV or the data set in input number 2. So data is equal to pandas.read underscore CSV T1 city consumption. That is also uploaded in the data set on my Beckett. So to see the features, so we have here the data head and the data tail. So we have 52,415 values, data sets on this data. So everything is present on this data set. So we are going to check to find out the missing value and the data types of the variables. So we have used the data.info. So we have here the range index is 52,416 entries. So data column is 9, which is also indicated in the UCI repository. So we have here, as you can see, that the date type is object. So we have to convert it to an object. Now, date time to data type, which should be the date time. So we have here the date time now has already converted. So there is one date time 64 and float there will be 8, so there's 9. That is correct. So we have checked it and it's already converted. So we are going now to transform the date time column to our index. So we can infer that the fact each feature simply displays numerical values that a possible production task will require regression techniques rather than categorization. So the next one, we have already checked it. So we are going to make the subplots. So data time has been changed. To plot the correlation matrix, Seaborn is used. So we can see the single correlation between each feature. So as we can see from here, based on the data with the temperature, humidity, all the wind speed, general diffuse flows, according to our database, 0.3, if the data is greater than 0.3, so therefore it's weak. If it's between 0.3 and 0.6, so therefore it's moderate. If it's between 0.6 and 0.9, therefore it is strong. And if it's less than extreme 0.9, no, greater than 0.9, it will be extremely strong. So however, the sun shows whether two components are growing in the same direction or in opposing direction. So our findings and the results. So we can see here that the power consumption for zone 1, temperature, humidity, wind speed, general diffuse flows, zone 1 power consumption in zone 2, and power consumption in zone 3. So we will have here the index of data features and the power consumption by hour. So now that we have the ability to box plot each characteristic, we can view the minimum, average, percentile, and maximum consumption of a specific time frame. So if we plot it by hour, the zone 1 has significantly greater average consumptions than in zone 2 and zone 3.